Okay, I know word problems are hard. I hope that before you watch these videos, you will try to do what you can and see how far you can get, and then come and see where you need to kind of gain a new piece of understanding, because watching the video and copying it down is not going to help you, okay? If you have not tried it first and tried to write something down and then just say, okay, well, what could I do next time to get another step further, okay? So we're looking at the problems on 2.3, and they're the word problems for number 1, and I'm not going to write the whole thing down because it would take too long and too much space, but it says for the Hawks 80 basketball games next year. Okay, so I'm going to write, anytime I see a number, I'm going to write that down. 80 games total. That's a total next year. I'm just going to put total just because I'll add to it if I need to later. You can buy separate tickets for each game at $9 each, so tickets are $9 each. So you can buy it as you go to each game. Or you can buy a season ticket for $580. Okay. At most, how many games could you attend at the $9 price before spending more than the cost of a season ticket? And let me write that. Before spending more than the price of a season ticket, okay? So you've got choices. You can buy your ticket as you go to each game, and it's going to be $9 a piece. Or you could get a season ticket and just pay for the whole season, and usually that's a little cheaper. So what they want to know is the cost. When is the cost of just each ticket? We're going to compare the cost of each ticket to the cost of a season ticket. Okay, and they want to know at most how many games could you attend at the $9 price before spending the cost of a season ticket. We could look at this either way and solve it. We just gotta. The thing about it is how you set this up is going to determine how you have to interpret the answer. So that's the thing here. We could make a couple of choices here. But okay, so if I'm going to buy, let's X be the number of tickets that I buy, and those will be the individual $9 tickets. So I know if the cost is 9X, and the cost of a season ticket is $580. Where's going to be the breaking point? I could actually solve this with an equal sign. That's the thing, is it's like, you choose, you can choose whatever you want to. Here's what I'm going to do. I want 9X to be less than 580, wherever that, as long as, when I get my answer, if I solve it this way, I got to think as long as X is less than the number I get on the other side, it'll be less than buying the season ticket, okay? So we'll talk about that answer when we get it. We can see that all we got to do is divide by 9, right? So X is less than, 9 goes into 58 6 times, and 9 times 6 is 54. So 58 minus 54 is 4, and then I carry down the 0, 40. 9 goes into 40 6 times with 4 left over. So as long as X is less than 66, let me check that math. 6. Oh, I wrote 66 and I said 64. That's what I tried to do for trying to do mental math. Okay, so X is less than 64.4444. Okay. So as long as I just go 64 times or less, I might as well just buy the individual tickets. But once I've gone over 64, I should just go ahead and buy. If I'm going to go 65 or greater, I might as well buy the season tickets, because I'm going to lose money. Even if it's just a little bit, I'm still going to lose some money by not getting the season tickets. So the most, basically, we could say is 64 times is really what your answer is, because they ask you at the most how many times could you go before spending more than the cost of a season ticket. If I had put the greater than sign, I would have had x is greater than 64.4, which would have been, you can't go to 0.4 of a game, so it would have been x is greater than 64.4. That would have still been 64. You're kind of looking for your boundary value in this problem, okay? If I had said x equal, I would have got x equals 64.4. That would have been the break-even point, so I'd know I could go to 64 games and spend less than $580, but when I went to the 65th game, it would have been cheaper to have gone ahead and bought the season ticket. So in some ways, this less than sign here, you could have maybe done it differently, but you just got to interpret your results correctly. Okay, I'm going to go ahead and work number 3. It says the length of a rectangle. Okay, so let me draw a rectangle. First thing I should do. The length of a rectangle is, so L is, means L is equal to 5 centimeters more than twice its width. Okay, 5 centimeters more than means I'm going to add 5 to something. And what am I going to add it to? Twice its width. So let's let W be width. Then twice its width would be 2W. And the reason we want to do that is we'd really like to work with just one variable if we could. Okay. It says find the largest possible width if the perimeter is at most. So the perimeter is at most. So it's less than or equal to 64 centimeters. Okay. Once I see that word perimeter, there's something else I should think to write down on my paper, and this is always true when you see something that you know has a formula. The perimeter is equal to 2 times the length plus 2 times the width. So my perimeter here is 2 times, if I want to get rid of the L variable, I can substitute in 2W plus 5 and then plus 2W. So the perimeter is at most 64 centimeters. So I want the perimeter to be less than or equal to 64. Okay? So now, if the perimeter is less than or equal to 64, and I know the perimeter is all this mess up here, then what I can do is just write that down. 2 times 2W plus 5 plus 2W, just substituting that in, is less than or equal to 64. So I'm really kind of building off this equation right here, and I go, oh, I can stick that in for the perimeter. So that would be 4W plus 2 times 5 is 10, plus 2W is less than or equal to 64. 4W and 2W makes 6W. 6W plus 10 is less than or equal to 64. And then I would subtract 10 from each side. 6W is less than or equal to 54. And then if I divide both sides by 6, W can be less than or equal to 9. And what did they ask me? They asked me the largest possible width if the perimeter is at least 64. So what's the largest one? Well, it can be 9 or less, so the largest value would be 9, whatever the units were, centimeters. 9 centimeters is the largest width. Try to get into a habit of writing your answer out to a word problem in a complete sentence, and always circle your answer so I can find it. Try to fit number 5 on here, and if not, we'll get what we can. Find all sets of 3 consecutive odd integers. So 3 consecutive odd integers. Whose sum is between 20 and 30. So the sum of the 3 consecutive integers is between 20 and 30. That's how I write that. And if you don't know that, that's going to kind of hurt you a little bit. All right, now, a consecutive odd integer, I'm going to kind of tell you 2 ways to do it. The way this book has always done it, remember you had the same textbook for your Algebra 1, so what they always do is they say, okay, if x is the first odd integer, how would I get to the second? I would say it's x plus 2, because I would skip a number to get to the next odd. That's the second odd. And then they would say I'd have to add 2 more to get to the next odd integer, so that would be my third consecutive odd integer. Now that's fine because our book has set things up where it works out right. I want to caution you though, if you're ever doing a proof, You cannot use that in a proof. In a proof, in order to guarantee that you had an odd number, because it's not, proofs are trying to prove it for any case, and this word problem is kind of specially set up to work without too much thoughtfulness, I guess you would say. If you were doing a proof, you would have to describe an odd number as an even number plus 1. So another way we could do this problem, and I'm not going to do it that way just because it is a lot more work. If you added 2 to that number, that would be 2x plus 3 to get the next odd, and then 2x plus 5 if you add 2 more to get the third odd. If you were doing a proof and it called for 3 consecutive odd integers, you'd have to do that, okay? So just a word of warning, because I know some of you may go on and end up in math theory classes in college. I just want to make sure that you kind of know that the only reason it's this simple, we're not trying to prove anything here, we're just trying to work a simple problem, and the book has kind of set it up to work this way. Even their solution guide shows you working with x plus 2, and x plus 4, okay? So if I'm to add all these numbers together, that would be the sum. That's what's in the middle, so all I got to do to get the sum is add those numbers together. So here's what I could do. I'll write it down and then we'll simplify it. 20 is less than x plus x plus 2 plus x plus 4, and less than 30. So I'm just taking that sum and substituting in the actual adding up of the numbers that they've talked about, the consecutive odd numbers. Now we just have to simplify. So we get 20 is less than, okay, there's an x and another x and another x, that's 3x, and if we add our numbers, 2 and 4 makes 6. It's less than 30. All right, I'm trying to get x by itself. So the first thing I do when I'm solving, I'm just going to solve here like I would with an equation. It's just I got to do things to 3 parts instead of 2 parts. I'm looking where the x is. You always find the variable. PEMDAS backwards says we add or subtract first, and we know we do the opposite. So the opposite of a minus 6 plus 6 is a minus 6. So we subtract 6 from all 3 places here. That's the only difference, okay? So 20 minus 6 on the left is 14. Is less than 3x because these cancel out. That's why we did it. 30 minus 6 is 24. Now we want to get x by itself, and so we say, well, in order to get x by itself, I need to divide that 3 off of it, so I have to divide all the numbers by 3. Well, you know, we're going to get a fraction, but big deal. 14 over 3 is less than x is less than 8. Now they want to know, the question was all sets of the 3 consecutive odd integers whose sum is between 20 and 30, okay? So the x here, the first one has to be between 14 over 3 and 8. Well, what is 14 over 3? Because it's kind of hard to think about that if we're trying to think about whole numbers, right? 3 goes into 14 4 times. That would be like 4 2/3 is less than x is less than 8. And they said, let me reread it, all sets of 3 consecutive odd integers whose sum is between 20 and 30. So if x is 8, here's what my possibilities are. And I'm going to write them in purple just because the space is getting cluttered and I need to look at what I've got here. So the first one could be 5, okay? And if I add 2, that would be 7. And if I add 2 more, that would be 9. And so let's add that up. 12 and 9 is 21. That is definitely between 20 and 30. So x could be 6. Oh, but 6 isn't an odd integer, so we can't count it. So we say, okay, well, where's the next odd one? 7, okay? Well, if you add 2, because remember, to get to the next one, we're adding 2 each time. 7 plus 2 is 9, and then plus another 2 would be 11. Now, if you think about the next number, it would be 8, but 8's not odd, so we can't pick it. And then if the next number would be 9, but 9's not less than 8. So these are the only 2 sets of consecutive whole numbers that would add up. So these are our solutions right here. 5, 7, and 9, and then 7, 9, and 11.